Hello, good morning to all of you. Those are present here and those are seeing this program offline, and myself Chanchal Das. Today I will be discussing on reservoir simulation. Reservoir simulation is a very vast subject, and I think it is a multidisciplinary subject. It is not possible to one person to master all the aspects required for reservoir simulation. So, I will try to cover as much as possible today, and there will be some interactive mode, and I have some my friends, those are attending this offline from Petroleum University, Pandit Dindal Energy University. So, they are petroleum engineers. So, this will be a what I should say interactive session in reservoir simulation, and I wish that my participants should actively participate. And yesterday night we had a IPL match here, and very late night we all enjoyed that tournaments, and the participants were more excited than the players. So, when I was seeing this excitement among the masses, among the people, those are they are in the field for observing the players to play. So, I was not looking at the players, I was looking at the people, those are attending there and their enthusiasm, and that time I was thinking that whether we can do something in mathematics. So, that when I will start some program or arrange some event like this, and thousands of people will enjoy and participate together in mathematics project. So, my target objective is that, and reservoir simulation is part of these efforts. And here a few thing about myself. I am Chanchal Das, and I was with ONGC for 21 years, and before that I was in Hindustan Fertilizer Corporation for 8 years, and then I left my job and started my journey in my own company. I have established 2 companies, Das Oilfield Technologies and then Das Scientific Research Labs Private Limited, and my intention was that every thing, almost I should say everything, we are dependent on foreign countries, and particularly when I was engaged in ONGC, then I have seen that all the service providers are from US, UK and Canada, and then all the simulators, they are also we are using from reservoir to that anything almost we are using their product. So, I was thinking that why we are still dependent on others. So, why we can't generate that technologies or the simulators or all those things. So, this was some point started in my mind, and then I started my own company after leaving ONGC, and then I have 3 inventions, I should say. All the 3 inventions are game changing technologies. One is a multiple zone oil completion technology. This technology is for solving a problem that oil industry face for more than 100 years. This is the problem of cross flow. So, in the cross flow, what happens when we drill one well, then we encounter multiple reservoirs on that, multiple reservoirs, but we cannot produce from the multiple reservoir, because this pressure having different for all the reservoirs. So, when we produce together, then this high pressure reservoir flows to the low pressure reservoir. So, that was a problem and it is called cross flow problem. And for that, what we are using many options, but very for me that options are very complex and costly. So, I was thinking whether we can do something to address this cross flow problem, and this is I think you can say this story is from 1990. So, long back I started working on that, and now we have a technology where we can use single well, very simple construction in that well, and this well can produce multiple reservoirs without any cross flow. That is my first innovation. And when we talk about multiple, so people may think it is 2, 3, 4, but it is not like that. In my case, we can produce from 40, 50 layers also if required. So, that much potential is there, and this is not that very complex. When we produce from multiple zones, that it will not go on increasing the complexity. Complexity will remain almost remain simple. What I should want to convey, that system will not become a complex. But at present, what we are replacing, this is a smart well technology or the intelligent well technology. So, we are replacing that. Now, we can one smart well technology may cost sometime 50 crores, 70 crores, 80 crores, but with my technology that same, more than that advantage we can gain with very less cost. So, this was my first technology. Second technology what I have developed is a gaming application. One gaming application, at a particularly contract bridge game I have developed. And what is that contract bridge game and why I have developed, that is also required. For me, contract bridge is a game, what I should say, best mind game. You know that we have mind game as chess. Many parents, schools, colleges, they encourage people to play chess. But for me, mind game is the best mind game is bridge, and bridge is such a game that it is provide you socialization. Every people has to come to in a place. They can play online also, but here what happens, the uniqueness of bridge is that it is a in one tournament hundreds of people can play. So, that is not possible in any other games. In any other games 12 people play or 2 people play or 5 people play, and rest see that their game. But here 100, 200, 300, 400, 500 players can play together, and this is the uniqueness of bridge, and it is a team game, pair game, and this requires huge coordination, intelligence will only not matter. So, whatever the properties required for living a healthy social life, all we can teach from bridge, and that is my motivation to promote bridge. And we have developed now a contract bridge app which can be played online, offline, both mode, and simultaneously hybrid mode. Some players can be in online, some players can be offline. So, this is and we are trying to excite that and corporatize that bridge game, in the sense that yesterday you have seen that winners got 20 crores prize, and runners up I think 12.5 crores prize. So, in bridge also at present bridge highest prize money is around 2 crores. So, we want to increase that excitement in bridge also and the prize money and other benefits also. So, that is another innovation, and third innovation is the mathematics learning. When I was a student, I faced some problem in learning mathematical concepts. So, majority of the concept was I used to learn at my own, and there was no problem. But one two issues I was facing that very starting basic level issues. So, what I should say, one determinant. So, determinant they cross multiply and subtract and they get a number, and I was stuck there. Why we do that? And I never find any good book where it is mentioned clearly. Everywhere determinant starts with that, even in higher secondary school also. Cross multiply the 4 elements of a matrix and determinant and then subtract and you get a number. So, it is very difficult for a student who is learning mathematics first time to understand why I should do that and what is the significance of that. And majority of the thoughts based on determinant is based on this basic thing. After that we learn so many formulas and other things. Similarly, you can see that matrices. Matrices is a group of numbers, it is very nice topic, but we directly start matrix and start defining hundreds of definitions involved in matrices. But why and where from these matrices come? Why where was the starting point? I got stuck there. So, like that so many small issues. If you do not feel any problem with that, you can score a high mark, but if it comes to your mind, then there is no answer in book. So, this sort of many small issues are there in existing mathematics learning system, and another problem is that nobody can learn mathematics at present setup at its own. Means if I want to learn linear algebra, suppose or suppose abstract algebra or modern algebra, then when I take any book, any very renowned author's book, I cannot learn myself. If I am not having a mathematics background, I cannot enter there. So, I want that should not be. Any person who is willing to learn abstract algebra, he should able to learn abstract algebra or modern algebra or complex analysis. Means self learning should be there. We should encourage or write our books in such a way or make our system such a way that a student can learn. They need not depend on teacher or Google or anything. Some material he should get so that he can start at his own and he can learn at his own pace and own time. So, that is not possible at present, and many of the professors, even if we go for a suppose 4th year professor, he starts some subject. So, he want that his student must complete all the basic things up to that level. So, this is another problem, and I am trying to solve this. So, these three are the game changing technologies what we have done try to do, and myself is a mechanical engineer with operation research in postgraduate diploma and a MBA, and I have received so many award till date, and World Oil Award is the highest award, one of the highest awards in oil field, and I received that as a innovative thinker, and there are so many awards also I received till date. I have published and presented many papers in different topics, and I am trying to make this mathematics learning through modeling, so that a student can start to play with mathematics. So, that is my motivation, and while playing they will become a mode self learning and self discovery mode. So, that is my objective in that, and I have written 4 books till date, and 5-6 books are I am writing, and my books are not in conventional way, all mathematics books, but in conventional mathematics book and my book is difference is that I am not giving any problem to solve. I am focusing only on concepts. So, once you go through that as a novel, you can learn the concept from A to Z. So, last time I presented calculus, and I summarized that calculus, so many big books are there, and myself that what is written in this book or what we learn from calculus. So, my one sentence reply was that calculus is the story of 2 lines. So, like that simplification we can do, and if you understand what is this 2 line, then you will understand better calculus than what we learn from these big books. So, with that I have visited many countries, and all these visits are mostly for presenting some papers or related some not this is leisure tour. When I used to go somewhere, I used to promote these ideas of mathematics teaching, and then earlier I used to present my many papers on reservoir engineering, and nowadays I am doing something also in bridge, contract bridge. So, with that I am moving ahead. So, here this applied mathematics, or I should say what I am trying to do, and today's lecture you may be thinking that I will be focusing on reservoir engineering, but my focus is not reservoir engineering. My focus is that how we can learn reservoir engineering through modeling and animation. That is my objective, modeling and animation, and once you know this modeling and animation, you can apply it in any branch. You can be a reservoir engineer, you can be a petroleum engineer, you can be a mechanical engineer, but the tools are same. So, I am trying to promote those tools, so that if you get those tools, then you can be a driver, not a follower. So, what is there in my tool? If I have to tell very specifically what actually I am doing, then this is the slide I am showing it, that when we think about some mathematics, then what comes in our mind is that mathematics is full of this equation, formulas, and symbols, and this is endless. It will appear that endless, but all these things if you think geometrically, then you can think that it is nothing unlimited thing. It is a very limited few things, which is that some point or some lines or some surfaces and some solid. If you know the properties of these 4 items, then this is the all equation and the formulas are related to these 4 things. So, if you can geometrically correlate your mathematics with geometry, then any mathematics will become very simple. So, and the example I have given for calculus is true here also. This current book, they have written this big book, 1200 pages, 1300 pages book, calculus, all are full of formulas and symbols and equations. But when I tell it that calculus is a story of 2 lines, then all the equations become a line and all the tangents become its another line. So, these two lines are play, and we go on describing this in different contexts, different situations, and different application in our daily life. But the basic thing remains same, that it is the story of two lines. So, like that modification can be done, and it can attract mass of the many of the students, those are not liking mathematics now. So, with this objective I have established this DasMath lab, and our Swaminarayan Institute of Technology, they are kind enough to provide me a very good lab, very large lab, and all the furnitures and PCs, and we have made many mathematical model there, and this I established. And the main objective of this DasMath lab, what we are doing, we are simplifying advanced mathematical concept. This is our work. We are not doing any fundamental research on mathematics. We are trying to simplify which is known mathematics in such a way that a PhD topic can be taught to a 10th class student. So, this is my objective of simplification of advanced mathematical concept. Another objective, you can say this, we should not learn means class 1 to PhD level. That means, if you can think 12 years, then 4 years, then 2 years, so then 3-4 years again PhD. So, 50% of our life is spent, or 1/3 or 1/4 percent of our life we spent in learning mathematics. So, when we apply that, so other objective is that it should be taught in school level itself, so that whole life they can apply it. And I am successful. One, at least I got one student who is 13 years age, 13 years of age, and he almost learned all the concept. At least he can tell about what mathematics is related to what, and he is applying those advanced mathematics in very advanced scientific thoughts. And I wish that hundreds of students also become like that. So, these are the objective what we do, this simplification of advanced mathematical concept, development of effective math teaching technique, publication of book, recognizing the mathematicians. There are a lot of mathematicians in the world, or mathematics teacher, they are spending lot of their time in developing some new ways of learning mathematics, but nobody keeps track of them. So, we have instituted some awards for recognizing their efforts, and fifth number is promoting and popularizing mathematics. So, I told you it should be popular like IPL, and organizing mathematics workshop. It should not be a dull, it should be enjoyable, not very seriously everything. We can have flexibility to exchange any ideas, and initiating Ganit pe charcha means you should start discussing on that. So, these are the thing. Now, what I am doing, I tell people that earlier we are living with a world where there was no technology, but now lot of technologies are available. So, with that you can solve any mathematical problem. So, for that what you are required to learn these three things. If you learn, you do not go back and learn reservoir simulation, learn computer engineering, learn mechanical engineering. You learn these three things: plotting, how to plot in graph. It is I am emphasizing in MS Excel because it is very simple and handy. That is all. All other packages you require to be a coder, or you should learn their code, what they have written. Here nothing basic knowledge is required to handle a MS Excel. So, that is why I prefer MS Excel, and it is having open source also Office. So, in Office package also you can use a spreadsheet, or for the same sake any spreadsheet you can use. So, but your thought will be you should learn the plotting, how to plot. Second is matrix multiplication, another thing that with matrix multiplication, one of my paper is there with mathematics matrix multiplication. You can do everything, even you can do solve the integration differentiation calculus, everything you can do with matrix multiplication, even addition of two numbers, subtraction of two numbers also you can do with matrix multiplication. So, that is another paper is there for me, and this is the thing. And third thing is the creating animation. Creating animation, it is very simple in MS Excel, even it is much complex and difficult in MATLAB, which I have experienced. So, that is another reason why I tell you to learn Excel. So, these three things, if you know these three things, these are the tools. What I should say, I can compare this as a you are a artist. You are a artist, but you do not have canvas and brush and the requisite tools to paint. So, your artistic caliber will never get out, it will not be known to public. When you can paint it, if you get the good brush, good paint and good canvas, then you can show your caliber. Similarly, mathematics, you can know lot of mathematics, but people will know what you know. These tools you can help you to explain people that yes, with this tool I can do this and I can do that. So, mathematics is not applied mathematics, I do mathematics in applied way. So, this is the main idea that nowadays we have so many technologies. One of the technologies I like, this best technologies is MS Mathematics. MS Mathematics developed by Microsoft, and it is freely available, but I do not know, people are not aware of that. You can do all the mathematics required for school level, college level with MS Mathematics very easily, and it is also very good graphing tool. In graphing tool, if you know the equation or function how it looks, then your learning will be 70%, and Microsoft Mathematics can help it. Then MATLAB, Mathematica, Scilab, GeoGebra, these are the good packages, but you have to learn some codes for that. It is not that you have to put their directives, you should learn their directives, how to use that, and then you can use those things. In Excel nothing is required, nothing is prerequisite, and Google calculator means you give the Google anything, it will give the answer. So many technologies are there. So, do not focus now on solving problem. At present the system is that they test your solving skill. They will teach you one formula and give 10 formulas problems to solve using that formula. So, that is the and when you can solve using that problem using that formula, you think that I learned mathematics, but how this formula is connected to whole system in our mathematics, nothing is known. So, now you should know what to be calculated, because you have the one technology which can help work for you, but you have to tell the technology that you do this, then only he can do it. So, this is the thing, and with this I have modeled in almost every sphere of life, including medicine. Here I have shown some use of this mathematical modeling with calculus. Then physics, I have modeled this projectile, then engineering, Watt's mechanism, environment science, Lorentz attractor, then nature, fractal geometry. All this modeling and every field, even 3D printing and this image processing, everywhere I have used this modeling and it is very good. And today I will be teaching this reservoir simulation. Reservoir simulation also my main object is not to use how reservoir simulation works, how you can use Excel to model and simulate a reservoir. That is my main objective. And this is actually I want that students should join my project, but what I till I could not reach them. I am in negotiation with state government to give access to the schools, and shortly they have agreed, and I may be getting 5 schools for experimenting my pilot projects with that. So, I want these guys class 8, 9, 10, 11, they should learn all the mathematics required for higher studies in school level itself, and that too in short period of time. It is not that they should spend 12 years to learn. I dream that the course taught in 12 years, if I can teach it in 12 days. So, very ambitious project, and I do not know how much I can do it, but this is my objective. And I feel that if I can do that, if I can achieve that, these people in class, whether it is class 8, 9, 10 does not matter for me, they can boldly tell, sir, I know mathematics, I know mathematics. Even I have seen many of the faculties, those are doctorate, postdoctorate, even having 10 years, 20 years mathematical teaching experience, they also cannot tell boldly, sir, हम कोई भी math कर देंगे. They tell, yes, if I am a graph theory, I can tell you graph theory. I am good in analysis. I have done PhD in analysis. I can do in analysis, but they cannot do in other mathematics. But life is required everything. So, everything mathematics, then they have to come with modeling and animation. So, coming back to reservoir simulation. Reservoir simulation, one problem I faced in last few days, I was trying to understand where should I start a simulation, reservoir simulation. And this is not the first time I am facing this problem, because reservoir simulation is a vast subject. Many other subjects are related, and you have to know the intricacies of each of these subjects, then only you can be a good reservoir simulator. So, initially I have done one online simulation, that is 1 hour program, 2 hour program in online, and lot of participant I received that workshop also, and it was good discussion, and many people are from foreign countries also joined in that workshop, and today also many foreign students also and faculties also joining this course online. But still that time also I was not happy, that much happy, because the message I want to convey, that I could not convey in that short period of time. Today I have 5 hours, and I will try to share my ideas today. I do not think today I will be able to go for any hands-on practice, but for that I will be thinking to put another workshop later. That will be also a part 2 sort of thing, where I can be explaining all the concept what I will be discussing today in geometrical mode, not mathematical mode. Today I will be discussing all these things in mathematical mode, and later on we will be next workshop I will be putting it in geometrical mode, and I will explain what is the mathematical modeling and geometrical modeling. Now, I have lot of interns from Petroleum University, and I think combinedly we can do that. So, where to start? This is a question. Whenever I start a new topic in mathematics or any where, I try to answer where to start, and here actually when I try to learn, then first I ask myself why I learn it and where I use it. So, similarly, when I am going to explain a reservoir simulation, then my idea is that where to start, and we will not answer this question now. We will try to answer what a reservoir engineer is required to do. If we know that what is a reservoir engineer required to do, from that we will try to answer where to start. Okay. So, this is my starting point, and this is I feel the reservoir engineer's first job. Reservoir engineers initially when they start their career, mostly they are engaged in data acquisition, fluid sampling, and all other related things, but in later phase they have to be a expert reservoir engineer, and they are required to be a good simulation engineers also. So, many reservoir engineers may not go for reservoir simulation, but those goes for reservoir simulation, their main work becomes like that. When we so what actually I mean to say here, I can demonstrate here in a. So, today is I think 30th May, no, and here the point I want to say that I was presenting this concept in many forums, many conferences, many other places, even invited talk also, but the problem I faced is that everywhere you are given a rationing in the time. Sir, you have to tell in 15 minutes. Sir, you are allotted to 40 minutes, or you have to allotted to 1 hour. So, like that, and whatever I had to convey, I have to convey it, and people listen that, and they goes back. That is not, I feel, a good way of teaching, and many things if we cannot elaborate, then it is very difficult to someone to understand why I am doing that, why I am telling that. So, I go for a little bit slow, but I want that people should go with me, and we start at a point and we will reach a point. I will explain why I am starting here and why I am reaching there, but we may be a little bit slower and little bit descriptive mode, because it is not that it is my first period I have to complete it 40 minutes. I have to convey my knowledge, what I feel I am having, to you, and you should take that knowledge so that you can use it in your career. It is not that something listening that today, otherwise today I will be absent and I will miss 75% attendance required, and that all are not there. Here sole objective is learning. So, I am going back to there. When we discovered a reservoir and think of reservoir, this is our reservoir. Okay. So, before discovering this reservoir, there are lot of activities, lot of investment, lot of people works on that, and their combined effort we discovered a reservoir and hydrocarbon reservoir. Okay. So, before that we invest millions of dollars, we can say crores of rupees we spend here. Many times we may not get the hydrocarbon and every expenditure goes waste. And then this is I called first stage of reservoir engineering or petroleum engineering. Then we drill it and we find hydrocarbon, and then when this hydrocarbon comes, then the role reservoir engineers start. Reservoir engineers come here. Okay. So, if it is dry hole, then reservoir engineer's role is not there. Reservoir engineer will not be knowing that all activities is done. But when we get the hydrocarbon, first job is evaluation of what? Of this reservoir, and data generation. So, this requires testing, reservoir testing, is not it? Reservoir testing, this is I should say in this whole petroleum engineering activities, this is I tell second stage. First stage, second stage, and finally, we establish this data, we establish this hydrocarbon potential, and then we plan how to produce, and then we start producing this. So, this is the third stage. So, in this third stage also, these activities are entirely different from this. You got it, my point. So, here what comes, how to produce, how much to invest, what will be the capital investment, what is the operating investment, and all those things, and how much we can exploit from this reservoir. So, this is the, suppose this is the N and we can produce NP, something like that. So, when here I had an article in ONGC that second stage cost saving tendency. Here we spend millions of dollars, here we require millions of dollars to spend, and in between here comparatively less cost, testing is not that much costly. But what in oil field we do, we try to cut short this expenditure on these two. And my article was a second stage cost saving tendency. So, second stage cost saving tendency, what I should say, why I should say, here we try to save. We suppose I am a reservoir engineer, I want to test fully that what will be the reservoir pressure, and for that I have to take a build up studies. Build up studies, permeability poor. If it is permeability very good, we get quick build up and we can shorten in one day the testing. But if it is a very tight reservoir, the time period will be long and we may take 3-4 days, but rig time, that time is costly. So, they do not want that 3-4 days rig time waste for reservoir studies. So, they try to cut short, and this is a fighting situation comes here. And here my suggestion here is that we should not try to we should test as much as possible. We should optimize also, because all this data helps you take a good decision here in third stage. In third stage, what we can do, we can minimize the cost or maximize the gain if our data is good. So, this is the basic reservoir engineering aspect, and today I will be talking about these practical aspects of petroleum engineering. Always speak on, because every one day rig cost can vary 5 lakhs to 1 crore.
Only owning the rig, then what's the problem with it?
It is I am a drilling engineer. The more I drill, I get more incentive or award or recognition or anything. So, if my rig is ideal for reservoir study, I will optimize, I will force you that you cut short. This is that. It is everything having its role, no. Production engineer, reservoir engineer. Production engineer, if they produce more, they will get good recognition, performance bonus or anything. And I know if they produce more, my reservoir can damage, it can cut water, it can start coning gas production, or it may have some negative impact of that production. So, what I will do? I will try to do not produce that much, you produce this, limit this production. So, this is a conflict, and he will always try to produce more. He knows that if you open the choke, it will produce more, but opening choke it is not healthy for reservoir engineer. So, we should convince him that you do why you should not do that. So, this is our mutual jobs. It is not that everybody want to optimize his own role. It is not that, and conflict comes there, and you have to good enough to resolve that conflict. It is not a fighting situation. You have to tell them that yes, you are saving one day rig time, but we are losing this data and effect of that in future. So, combinedly he also agree, and we used to do that reservoir testing planning. When we used to write this, no, there was a lot of chemistry chemical engineer. You will feel that chemistry people will not come in picture, but here also chemistry people has a role. Sometime we ask that we discovered a reservoir, then after testing we want that reservoir should be subdued with some mud, and the heavier the mud, more the damage. So, now I know the reservoir pressure, I will ask that chemistry department that you use this less weight mud, so that it will not damage the reservoir, but they are concerned about safety. They knows if it becomes, if it is some imbalance happens, it will blow out. So, they will not agree on that. So, they want to hire mud. Like that, everywhere conflict, every situation having a conflicting situation, and good engineer has to, you cannot dictate anybody. You have to be scientific, you have to be your ideas should be convincing, and it should be an adaptive situation, coordination. The more you good in coordination, convincing, then more healthy situation will happen, and company will gain. So, with that now question comes that I have discovered a reservoir, I have option that I have drilled one well and produced from that. So, I have another option, I produce 2 well, I drill 3 well. So, that the more oil, more production, more gain. So, everything is acceptable. Then comes whether it is horizontal well or vertical. Some engineer will tell you drill a horizontal well, or and someone tell vertical well. So, all these options go on adding, and you have to choose. 3 wells means 1 well cost or average 10 crores to 20 crores. So, 3 wells means 60 crores, you are investing 60 crores. Then whether it is justified, the gain out of these 3 wells and 2 wells and 1 well, all these things. Then this is depletion mode, means nothing you are adding extra. Then idea will come that if you go for water flood, it is known water flood production will be more, but water flood production will be more, we know, but it is not free, no, it is required cost. So, when we require a water flood, suppose injection you require a injection well. Now, water flood casually if I tell, it is required injection well cost. This actually this presentation again some having I should have some clarity. I am focusing my audience, I am focusing that those are budding petroleum engineers, this talk. So, I am going to some extent very basic and also to some extent very initial thoughts. So, injection well cost, water flood, immediately you require an injection well to inject water, and that will add cost. Again it will be 10-20 crores depending on the depth and other parameters. So, then the factory I tell it factory because it is a something there you have to purchase a land, you have to put a setup there, put injection pump, you should get drill some well to extract water, and then you have to purify or clean the water, you have to make compatible with this reservoir water. You cannot throw any water there, that water also can damage here. So, that compatible water, so water processing. So, water processing, this water injection mechanism means you have to put pumping and other things. So, there also if you produce think of water and then polymer flood. I am telling very small things comes go on adding. So, in polymer flood everything will be same, but in water processing you can use this pump. This pump can be centrifugal pumps, but if you are using everything will be same, but pump should be some displacement pump, reciprocating type. So, you can see from this every idea, every plan having some why we should not use centrifugal pump, why we require to put this displacement pump or reciprocating pump. So, all these things again comes mechanical engineering. That is why I was telling reservoir engineering is a multidisciplinary subject. So, this thing. Now, water flood, polymer flood, there can be again option for this is actually depletion drive. So, there will be again thermal. Somebody will tell that this reservoir, nearby reservoir, they are using thermal process. So, you use their thermal. Why we then again there will be a factory, there will be other setup and all those hot water air is to be compressed air is to be sent and all this activity will be there. Then there will be a surfactant. Then there are many other things. So many options are there, and reservoir engineers are required to do. I have written there last line, you can see that there are hundreds of options, and you have to choose one, and you have to not only choose one, you have to justify it, and that justification reach up to ministry level, because anything you can't do arbitrarily. So, I have shown something, try to say graphically. This actually I want to do, graph means geometrical modeling. So, if you have a reservoir left side, this big size reservoir, and you have many options for production 1, 2, 3, 4 as I have written here, and then depending on this option their NP means net production will be of different types, means quantity. It is not that everywhere will produce, somewhere it will produce less, somewhere produce more, like that, and all these options having different cost component, and it will be cost will be that vary, and in doing all those exercises your main focus should be NPV, which option gives me maximum NPV, and this is the reservoir engineering job. And to establish these facts, actually we require reservoir simulation. This makes sense. So, and telling all the time required, it is years, sometimes 2-3 years. So, this is the problem, all these things. So, with that I let us have a break. Okay. Then what I will be doing, I will explain the case of this Shannon field. Shannon field is a ideal case of for reservoir engineers. There are many fields in India, but I choose and I like the case of Shannon field, because all the reservoir engineering aspect is required to handle a field like Sanand. Many fields are good fields, there you need not be a good reservoir engineer, anyone can produce that. But this Sanand field is required very specific policies, and there are multiple options, and all these options are conflicting options, and not only conflicting, it is debatable. It is debatable, and if you are a reservoir engineer responsible for these options, then you have to justify all those things in scientifically. Okay. So, this roughly I will explain this. In short, what I tell you that this is the starting point. Depletion drive recovery. If we had planned this Sanand field, if we go for depletion drive, as I told you first case, we will drill few wells and go produce from that. So, maximum oil that you can recover from that scenario is 14% only. So, in that case 86% of the oil will remain underground, and you know that this is not a good option, is not it? But again you can say that you can go for water flooding. So, water flooding also in one sense is not that good option, because in this case though many field water production gives you 60-70% recovery, but this field is 15%, only 15%. So, the recovery is only 15% with water flood. So, if you go for depletion drive, it is 14%, if you go for water flood, it is 15%, means 1% incremental oil you will gain, but you have to drill the injectors and then establish a factory for pumping those water and then processing the water, all those and pipeline of those water from your factory to wellhead. So, all this expenditure only you will gain extra 1%. So, not a good option. So, then we have used a polymer flood, and polymer flood again it requires establishment that polymer injection plant and all those things, and with that we could recover 24% till date. I am giving this figure for 2007 when I studied this field, and by that time 24% we have produced, and we are envisaging we can produce 36% total. So, these are the things. So, now I tell it, but who believes it? As a manager, will you believe that water flood will be only 1%, and if you go for polymer flood, it will give 10% extra. So, I have to justify. How I can justify? And the role of reservoir engineering comes here. And if you are a good reservoir engineer, you have to explain every aspect mathematically or scientifically, and that is our objective today. Okay. With that, we are taking a tea break, and after tea break 15 minutes. So, 12:35 again we will be meeting. Thank you. welcome back to our second session of reservoir simulation in MS Excel, and myself Chanchal Das, and we are talking about this Anand field, and there are lot of options available for exploiting this reservoir, and we have to choose one option, and not only we have to choose one option, we have to justify it. So, that was the issue, and I think this is true for every reservoir engineer. They will face many different types of reservoirs, and their exploitation strategy will be different. Hundreds of options will be available for exploiting those reservoirs, and they have to choose one, and they have to justify the reason for that technically, scientifically, mathematically, and all possible courses, because every option having some outcome, they can extract some oil, and at the same time they have to invest some money for that, and that should also balance. So, both economical and technical feasibility has to be established, and this is has to be done by reservoir engineers. And at the same time, I tell you that reservoir engineering is a multidisciplinary subject, and though it is a reservoir engineer is responsible for all, but a reservoir engineer cannot be a expert on all the disciplines. So, he has to act taking all them into consideration and coordination with them, and then only we can get a very good result in reservoir performance analysis or simulation or net output from the project. So, with this options I have seen that in depletion drive, what is meant by depletion drive means we are not using anything, we just drilling a hole well, and 1, 2, 3, 4 wells, and then we are producing from that, and the amount of oil comes till it pressure depletes, we take all this oil and materials there. So, if I follow this process, we can recover 14% oil only, and then we analyzed that what will be happen when we go for this water flooding recovery. So, water flood recovery, it is also seen that only 15% we can recover with water flood, and 85% oil will remain there. But in general, what happens in many favorable reservoirs, with water flood we can recover almost 60-70% of oil. So, it is almost opposite to the general belief of benefits of water flooding. So, this is another question reservoir engineer has to reply, that why it is not 60% or why it is 15%. Anyhow, lastly we have taken the option for polymer flood project, and this polymer flood project also now we have already produced for 24% of the oil and 10% additional oil than depletion drive, but for that we have to deploy polymer flood project and polymer injection plant. Polymers every day we have to inject use polymer in that, and with that we could achieve this 24%. Here also many people ask that we might have achieved this 24% without polymer injection also. So, a reservoir engineer has to defend that also, and many other engineers can ask why you are going polymer flood, you can go for surfactant flood and you can produce, and or you can even go for water flood and produce. So, he has to justify that why that will not help and why only polymer will help. And then there are many other questions, relevant questions is, if it is polymer is so effective, then why you are using polymer only one field of India? In India, ONGC has lot of fields, and why you are using polymer in one field? So, that also you have to justify as a reservoir engineer. Actually, all fields are not fit for polymer floods. Polymer floods can be applied for specific fields, and that is the reason why we have taken Sanan field for that. It is a very good candidate for polymer flood, but it is, I know that, but I have to convince others that is required. So, why I have chosen that. So, all these combinedly we can do with reservoir engineering techniques or the reservoir simulation models, whatever is that. So, with that I am moving ahead. I will briefly tell about this Sanan field, what was the problem. Sanan field actually it is very near to us, this Gandhinagar, and it was discovered in 1962, and 1969 onwards this field is producing, and still it is in under production. So, everything was fine, and from this structural contour map you can see this first well producing well Sanan 15 is in the almost crystal part of the reservoir, and these are the some properties of reservoir. Initial reservoir pressure was 142 kg per centimeter square, and then current reservoir pressure around 100 ksc, and bubble point pressure 80 ksc, and datum depth is 1325 meter, and temperature 85 degrees centigrade, oil specific gravity 0.92. Oil viscosity, this is an important parameter. Oil viscosity is 20, and then porosity is moderately high 24 to 32%. Oil saturation is comparatively low 50 to 60%, and permeability is good enough 1500 millidarcy. So, these are the parameters of the reservoir, and some parameters are very good and favorable, and some parameters are not favorable. One of them is bubble point, and another is the oil viscosity. So, these two are actually playing a major role in exploitation of Sanan field. That is the main presentation of my paper, and these are the chronology of the reservoir. It has started first production 1968, then 85 we had used some pilot project, then 95 commercial project we on polymer flood, and still it is under production. So, that structural contour map I have shown a graphically right side. You can see this is the oil at a crystal oil, but and it should produce pure oil, but after 15 years of production under primary depletion, what happened? These were additional wells, subsequently we drilled and started production, and the problem started here. You can see that every oil having a percentage mark, 30%, 40%, 15, they are 22%. What this percent actually means is that these oils are started water cutting water, means oil production was there in addition to their 40%, 30%, 35%, 22% water cut started. So, though we are not injecting water, any water, then even though it was producing water. So, this was a point of concern actually, and For that we have first started a 5-spot polymer flat project and 1985, and it was not that much effective, and then it was extended. Then there was a 4 injector and 9 producer, and withdrawal and production rate almost to some extent equilibrium, and still there was not that visible gain. Then we extended this polymer in different phases, and in this extended polymer phases we could able to arrest the water production from the reservoir. So, these are the curves of the production. Blue curve is showing the water cut, and brown showing oil rate, and you can see this water cut was increasing in 90 onwards. You can see 88, 86, 85 water cut started increasing, and there was some number of producer also. You can see this we have increased the number of oils, that is pink color, and in the graph, and in spite of the additional oil we drilled, the oil production was not proportionately increased. That and that is the problem, and bottom graph shows the injection quantity of polymer. So, these are the graphs. These graphs I wanted to show that this number of oils went on increasing, but comparatively production was not increasing, rather it has a decreasing trend. So, these are the issues I told you in first slide, that we have used polymer and now we are gaining, but a simple claim will not help. We have to establish it scientifically, and that is the objective of this presentation. So, first thing we tried to analyze the region of water cut. Region of water cut calculation, these are the things I want to teach the budding engineers, that this is a technique which is called Hablena-Ode material balance technique. Here this in this technique what we can learn, that whether this reservoir is producing any water or not. If this curve this we are F by EO is equal to N plus W E by EO, this curve if we plot with the NP, then it will, if it is a upward trend, that means extraneous some fluid is entering into the production, and that is indicative of the aquifer. There is a presence of aquifer. Here I want to tell that in classical reservoir simulation, we beforehand we take as aquifer strength is 0, and then while history matching we try to match the water cut by increasing the aquifer strength in simulation model, and we can match that, but we are not sure that whether it is for from aquifer or something else happened. But here we can very well calculate. This is analytical calculation. This gives a confidential confidence that yes, it is some extraneous water is coming. So, from that we can say that this reservoir having aquifer, and this is I have shown in this is in this right hand graph, that water is right hand and left hand edges are there. This is the water, this is a sectional view of the reservoir, and on this red color I indicated oil. I think this color code is not right anyhow. So, here we should get only oil, but this water was that long distance, but still this water started producing in Sanan 15, and this we could establish that this Havlena-Ode model has helped us to identify that there is an aquifer acting. Now, when aquifer acting, this is having many positive and negative implication. A positive implication is that it can help you in more production, because in water plant also we want to inject water, and then we improve the recovery, and here nature is helping us. Nature is helping us in as injection oil, and it is helping in oil production. So, this is one way is favorable to us and good sign, but it is having a negative sign also, because this water is having only 0.38 centipoise viscosity, but our oil density, oil viscosity was around 20. So, that is making the mobility ratio of water and oil is adverse, and due to that water becomes more mobile than compared to oil, and the water instead of pushing the oil towards oil bore, it is itself is producing to the oil bore by cutting in the layers. So, water cut is going on increasing. So, that is a negative aspect. So, positive aspect, it can help in maintaining reservoir pressure, at the same time it can help in more production if the mobility ratio is negative. So, means favorable. So, in that way both we have seen that this Havlena-Ode model helps us to identify the aquifer presence, and then we have to establish that how it is helping in maintaining reservoir pressure, as well as it is helping in recovery. So, with that what we have done, we have taken the fluid PVT analysis we have done, and all this calculation I will show later, that it is in undersaturated reservoir, and bubble point pressure is showing here at around 80, and at present pressure is 100, and initial pressure was on 42. So, here we right hand side what we have done, if it is a depletion drive mode, then how much it would have produced, that calculation also I will show later, that this will produce only 2% of the total oil when it depletes at pressure 80 Kc 142 80, when it will come we can produce only 2%, and it is not my claim, it is also calculation. I will show how we calculate that. So, this was the actual field data. Here we are expecting that when it is produced under depletion drive, it should follow this blue curve, but in actual case you see that production was going on, NP was recovery factor was going on, but pressure was not depleting. So, this is also one indicator that in this reservoir very active aquifer is there. When we are lifting any fluid from the well or reservoir, this aquifer is expanding and trying to maintain the pressure. So, this is the other issue. So, though the aquifer, if it acts as a water flood sort of thing, we can require more oil, but here also it is maintaining pressure, but our recovery is going down due to adverse mobility ratio. So, here I am telling that this higher viscosity leads to adverse mobility, which in turn result in earlier breakthrough of water, reduced aerial vertical sweep efficiency, higher producing water oil ratio, lower water flood recovery and longer project life, higher operating cost. So, many things are interrelated with simple viscosity, the oil viscosity is so important in this case. Now, you think this reservoir is like our Ankleshwar field. Ankleshwar field is almost 0.5 or 1 centipoise oil viscosity. So, this reservoir having this Ankleshwar oil, then we could have produced without any other means maximum or at least 60% oil we could have produced from Ankleshwar project. But Ankleshwar project having another problem, this is having very high water saturation, that is another case, but in this case viscosity is playing the role. So, here I have tried to explain what happens the fluid flow in porous media. Left side I have plotted with fluid, oil and water, how they behave in reservoir flow. So, what happens, the saturation of the fluid dictates which fluid will flow at what rate. So, Kr is the relative permeability and horizontal line is water saturation. So, 0.26 or something I have taken, this is connate water saturation, this point, and in this connate water saturation there will be no oil water flow. So, almost you can say that relative permeability of water will be 0, and in this situation the maximum Kr oil is maximum, that means most of the fluid flow will be oil. So, we will get pure oil without any water. So, this is the most favorable condition, but if the reservoir saturation or water saturation goes on increasing, then relative permeability of oil goes drastically down, and what will happen in turn result, water cut will go on increasing and oil production go on decreasing. So, in this case when the water saturation comes to you can say 45, 46 or 60%. So, we will go on getting more and more water and less oil. So, in that case it will become not a oil, it will become a water oil, and maximum fluid will be water and some oil will be mixed in that. And some our fields in ONGC is like that now, almost some fields producing 95% water and 5% oil, but we cannot ignore that 5% oil also. This is also a huge quantity, but to get this 5% oil we require to process this 95% water. This is a huge quantity of water, and this is not pure water, this is a water saline water and reservoir fluid, and we cannot just throw it, we have to process it and then we can expose it to the field or inject it somewhere, and this is involved huge cost again. So, all this improves the operating cost, and this next fractional flow curve is shown, that how this water cut will increase with this reservoir water saturation at the bottom. and recovery factor also goes on. Pore volume injection, here you can see that 50% recovery, and PVING 1, 2, 3, 4 is the pore volume, means if it is there 1 million ton oil, then we have to if we inject 1 million of water, then we can produce 0.3% here at this point, 0.3% water oil recovery. So, these are the things, but it is to be proved, it is not to be that just it is not that my imagination, it has to be scientifically proved, and this we can do very easily analytically using Excel. So, the trend of water cut in plot in 1992, what I have plotted, the recovery was going on. So, 0 to water recovery right side, and water cut, you can say that in 12% production water cut is increased to this water cut increased to almost 80%, and if we extend, then it will reach soon in 100%. So, this was the problem we had in Sanand, that if we have if we do not work or if we do not act something differently, then very soon we will be producing 100% water instead of oil. So, this was the problem, this was the problem, and this is very well visible here, the trend, what was the production trend that time. So, if you cannot plot this properly, if you do not know the effect of these things, so then you will never realize that what problem the reservoir, because you are getting oil, some oil in surface, you are happy with that, but you will not realize that what is going to happen in future. So, in future shortly it will produce 100% water. So, at bottom I have written what can be done. What can be done? If you think that what can be done, we have two options: increase oil mobility. Oil mobility, we have to increase the oil mobility. How we can do that? We have to reduce the oil viscosity. What we can do for reducing oil viscosity? We can either use thermal process, when oil gets heated, it becomes more mobile. So, we can use that, that is one option, and second is reduce displacement water mobility. Displacement water mobility, what is mobility? We can decrease, we can increase the viscosity of water. So, how we can increase the viscosity of water? We can add some polymer. If we put the polymer, then oil will become more viscous and mobility will be reducing. So, when oil mobility reducing, then it will move with oil. So, oil will produce first and then it will be pushing it. So, these are the things, this is my options, and thermal was one of the negative aspect of thermal is that when we process a thermal process, everything gets heated, and heat generates lot of other technical issues, including this metallurgy of the oils and all the producing fluid, handling of producing fluid, everything having some negative effect, and wherever we can possible, we should avoid this thermal process, and then we can go for second option. Second option, what was the second option? Reduce the displacement water mobility. That means, I am telling that you increase the viscosity of the water. So, how the effect will be increasing the viscosity of water, that I have depicted here, and these three curves has been generated from this one relative permeability curve. So, relative permittivity curve, here you can see that first curve which is having water viscosity around 35, second one water viscosity 2 and last one is water viscosity 8. Last one water water viscosity 8 is last one and middle one is 2 and left side is viscosity is 35. This minute. So, left one is water viscosity is 0.35, middle one is 2 and last right hand side is 8. So, what is the implication? We cannot go on increasing the water viscosity infinitely, means we cannot make it water viscosity 30, 40, 60, 80, 90, 100, because everything having a limitation. Even we can able to do it, we can face problem in injecting that huge viscosity thing. So, this is 35.35 is the when the viscosity is that, then you can see that how steeply this water FW is frictional flow of fractional flow of water. So, how fast it is increasing and with water saturation. So, slight increase in water saturation, the water cut goes hugely up to 80%, 90%. This is the trend. So, what will happen if we increase the water viscosity to 2, then the pink color curve will be followed. It is a little gentle curve. So, water saturation goes on increasing. Water saturation goes on increasing, it implies that oil saturation is decreasing, and oil saturation is decreasing implies that more oil is being produced. So, here and last curve, when this water viscosity is 8, then you can see that water so many water has been saturation has been increased, that means that proportionately oil has been produced and still water cut is not increased much, and that is the desirable thing. So, what we have done, this another curve you can see that it is some curve like S curve which is increased and then decreased, then again following this last line. So, it started in first leftmost curve, then came down and then following this rightmost curve. So, this curve what it gives, at this point we have added polymer. When this we added polymer, then the viscosity fractional flow of water reduced and we are started getting more oil and less water. And the effect of this is that you can see that viscosity of water 0.4. In that case, the bottom one recovery factors line, recovery factor lines, it is almost never can go beyond 50%, and last the x axis is pore volume injection, means how much water you are injecting. So, if you go on infinite injection also 5 times of the pore volume, then also you cannot produce more than 50%, and this is a very costly affair. But the top curve it is having viscosity of water 8, and you can see that initially itself you can produce 50%, 60% like that, and without 0.5, 0.6 pore volume injection. So, pore volume injection implies that you can inject little amount water and you can produce more oil. So, this is the thing we have done in reservoir Sanand, and now the performance of this field is that you can see that it was 60% oil saturation, water saturation it is started, and then it is not going upward, it is having a downward trend here. It is shifting right side, that means water cut is decreasing, and this is the trend actually I have seen, and the first trend would have been 100% water cut at 15%, 20% water saturation recovery. Now, it is following this inclined curve. So, this is I have seen the two condition, additional oil what we are getting, and conclusion is that improving recovery from the field Sanand, when we produce the field with what I should say water polymer flood, we could improve recovery from the field, retarding the rate of increase of water cut. This is also a important objective, because the more we produce water, our operating cost goes on decreasing, and the production period, operating period goes on longer and longer, and both having huge effect on NPV. And reducing the encroachment of aquifer, when we started injecting polymer, then this aquifer water is not encroaching much, though it is maintaining pressure, maintaining the reservoir pressure above bubble point, stopping the free gas production. Maintaining the reservoir pressure above bubble point, it is about having a implication is that we will the gas will generate in reservoir and gas will not flow much. So, we can produce more number of oil and improve residual resistance factor, thereby reducing further increase in water cut. Water cut will reduce. So, this is the a case study of Sanand. So, now question comes where we should start, what is the relation of these findings in reservoir simulation. So, I am trying to explain that we have some book what I followed, it is Principles of Applied Reservoir Simulation, and by the way I should say that I have used IMAX, Eclipse and CMG star, and this is a rare opportunity, because these licenses are very costly license. So, even you are very brilliant guy, you never can get access to those simulators. So, I could get that when I was in IRS, and I could learn both simulators, but there I was not that happy, because all these intricacies I used to get some data and I used to get some output, but I was not happy with that ki which factor is affecting what, because you can match the curve in 100 ways. You can increase the relative permittivity curves, the slope you can change, you can do something here and there. Like that there are lot of options are there to match the curve. So, when reservoir field data matches, then you cannot make yourself happy that I have done lot of things is not it. So, it can be matched, but you have to write reasoning and means calculations to establish that reasoning. So, this book is good book, and I wish that you your library may have you can get this book, and this is another book. This is Applied Petroleum Reservoir Engineering by Kraft and Hawkins. These two books was my favorite books. In addition to that, LP Deck, then Tariq Ahmed, these books also I enjoyed reading. But basic book is Petroleum Reservoir Engineering by Craft and Hawkins. All other books are almost, you can say that they have made the simplification of the ideas given in Craft and Hawkins. They have created more formulas, more problems, and it has made more simplified way they have written all those books. But the parent book, we should say, Craft and Hawkins, this is a very good book and I followed. So, you can follow this book also. So, from this fancy book, I have tried that when I want to go for a simulation study, where I should start. So, this is the thing, this why it takes 6 months, 1 year, 2 year for creating a reservoir simulation is this is the reason. Seismic interpretation data, it requires petrophysics, it requires fluid property, requires oil, requires model grid, requires tubing curves required, facilities required, and all these things combinedly we can create a numerical simulation model and these things. Okay. So, here also I was not happy. Here also I was not happy. Why? What is the problem in this? Can anybody tell? Any idea? Path? Can you tell something? Take mic, yes. This looks very good, no? Yashan.
Sir, maybe as per your interest, there is no geometry coming in.
Geometry coming in the geological model, no? That is geometry.
Because there is just data and you are
no,
just
it will
interpolating the
create
data
a
points.
model also, no? They will create a 3D model. Geometrical model is there, no? Left side middle.
Okay.
So, my point was that my point was that I am a reservoir engineer, okay? And where we started this, we started at all the seismic drilling, all the activities, surveys, stage 1 has been done. Then stage 2, discovery. Okay. Now, stage 3, now they can give you some data, seismic data, geology data, that you can put here modeling, and you know this is also required interpretation. All these data generated here, except drilling, all are indirect inferences. All are indirect inferences in the sense, suppose there are 5 layers, Stage 1 means when I yesterday I told you that I have went to Uganda and I have approached your government, I want to explore oil here. I got a license. Then I started activity. So, what will be their activities? Stage 1, I will be taking some seismic survey, some geological survey, some other parameters, gravity survey, whatever may be, to find where is oil. And then after getting sufficient data and confidence, I locate one point to test whether it is a hydrocarbon bearing or not. So, I drill. So, all this activity I am talking about stage 1 activity, I should say petroleum engineering activities. Good question actually, because when we talk, I am thinking that you will understand that, but it is not the case, because you are not. I am having something in my mind, and from that I am talking. You don't know what is in my mind. So, your question is very relevant. So, activities. So, stage 1 activity is there, and we spend lot of money for that, is not it? It is not free. All exploration, licensing, everything. So, stage 1. So, then discovery, and then when discovery, then my role as a reservoir engineer comes here. I do some testing and evaluation here, and should I wait for 10 years or 5 years that you make all this modeling, whatever I have seen that chart. So, all this activity is not overnight can be done. It requires 4-5 years. Should I wait for 4-5 years to model and plan my exploitation strategy, or I have to something to start exploitation something immediately. So, if I require to do something, and everything involve cost. So, we have to do something. I cannot follow the path, the figures I have shown there, and many of the data will not be available there also. Even fluid properties also, we many times we may sample, or many times we may not be even sample the bottom hole fluid. So, fluid properties also not that much available. So, all these things are there, and this is the thing. And what we can do, we can better we can do some analytical calculation. Analytical calculation definitely will give you some confidence than over others, because here also when you start seismic interpretation, geological model, petrophysical things, and I am telling that all these activities, it is indirect inferences. Indirect inferences, what is that? Suppose take a case of gravity. We measure gravity of two areas, here gravity more and here gravity less. Okay? And from that, what we are inferring, that it may be porous, is not it? So, this porosity is we are inferring from that gravity. Directly we are not measuring that it is porous or not or something. We are just assuming when it is lighter, then it may be porous, but it is not necessary that porosity required lighter sand, or the lighter sand will be porous, not necessary, no. So, all this if you think that all these things are indirect inferences, you do not know about actual what is there. So, indirect inferences when you do, there are lot of options for the same event. Suppose I got here 100, this gravity is 100. So, I may tell it is definitely porous. Someone will come, no, there is a material which is whose density is 100. So, it may be that material and that is not porous. So, there is a lighter material which is not porous. So, like that. So, conflicting things are there, and with that you have to work. And if you require to, okay, let us see whether it is porous or not, let us drill a hole. And that decision again, it may be 10 crores, 20 crores, 30 crores. It is not in few amount, huge cost involved in every activity. That is the another uniqueness of oil industry. It is cash rich industry. You require cash, and you have to aptitude of taking risk. You may fail, you may gain. When you gain, you will be a king, and when you fail, you will be a poor man. And there are a lot of stories on that. You know that in the world, one of the richest man, no, I have not heard about his name. Who is he?
The owner of the owner of the first oil company in America. I don't remember the name, from where the 7 big oil companies have formed when his company
Struck oil.
huh?
Struck oil.
When his company declined, 7 oil companies were formed. ExxonMobil is one of them. Then Royal Dutch Shell is one of it.
Okay.
One of the 7 companies.
Okay, I don't know that story, but I know one story of Mr. Baku. Baku field is near Azerbaijan, Baku, Georgia, Russian, near Russian field. So, what happened, there was one saying, people used to feel that there is oil, and one fellow, his father was shoemaker, and he believed on that saying that there is oil. So, he started many tricks. There was no drilling rig and other things available that time, no, long back. So, he was trying to drill some by means of some wooden logs and other available resources, and he used to spend lot of money for that, and almost every time he was failed. So, he is but one fine day he succeeded, and the person is the richest become richest person in that region, and he brought all the European architects there for constructing his building capitals and other things. So, if you anytime go to Baku, you can see that almost will see that the buildings and other structures almost are like Europeans. He has become so rich on that. So, like that if you strike oil, then you can become a very rich man, but for that you have to take huge risk, and that is why many people avoid investing oil company. And my experience I should share also. I was consultant with Jindal, and Jindal has acquired a very big, very large oil company which is producing at more than ONGC at Georgia, and that time Georgia was under Russia. So, they acquired very comparatively cheaper rate, and they started production. But what happens in there, when there was a revolt and Georgian was freedom fighting all this, and they have to leave, Russians has to leave the Georgia. But while going back, what Russian people did, they destroyed almost all the oil wells present that time. So, majority of the oil wells, and that field was acquired by Jindal. And after few years of production, every field started cutting water, almost I told you as 95-96%. And that time I was being engaged as a consultant reservoir engineer there, and I had many ideas, but I could not implement it, because already some projects were in pipeline, which was very costly projects. And when I went there, I told my opinion that this will not help because of some reservoir engineering aspect, this investment may not help. But they went ahead with that investment. This was a huge investment, and it proved nothing, no gain. So, Jindal then was very annoyed, and he sold back all the asset in Georgia. So, one wrong reservoir engineering decision can ruin a company. Similarly, another 2-3 companies I can cite, those are ruined because of bad reservoir engineering decisions, though they are a good company. Anyhow, so what I mean to say that oil companies are very cash rich company, and you have to be risk taker if you want to work on oil field. So, here I am telling modeling is an integral part of simulation. So, as I told, modeling you have to do it, but my modeling and this modeling is entirely different, and reservoir model is to be prepared before running any simulation. But here the point I raised, I have just discovered, I do not know even extent of this reservoir. So, how I can model? I require to wait for 5 to 10 years, so that all data comes, compiled, modeling made, and then I will take a decision. Company should wait for that period. So, that was the argument with me. I was not happy the way it was being done, and these are the quotes from that book, what is being practiced. The model generally is generated in 2D, and then it converted into a 3D structure using 3D platforms. Here also a trick is required, which is computer graphics related problem. This is the model I teach you, and they do apply same technique, but in different way. So, this is the activity in modeling, and collect and study the structural contour map, isomap. These are the steps what are being followed. I am not going point by point, just I am mentioning something. Collect and study structural maps, then collect boundary, start grading. Grading means you have to make the small grids. Here you have to have clear knowledge on how to make a surface or the grids. If you are not good in that, this is the modeling, my modeling, that is the my way, because it should be a handy model. Handy model, it can be one cell model. One cell means I take this entire room as a one reservoir, and I can act on take decision as a simulator. I can make it in 100 by 100 or by 100 pieces, and I can make it, but my model I should make, and you should have clarity on creating surfaces for understanding what is a structure contour map. I have seen many of the people in ONGC, they deal with this structure contour map mechanically as the written in the simulation book. They do not have any understanding of how this surface is being made and how it is converted into the model of reservoir model. So, this is one point I want to share, and I want that if you work, we should learn this technique also. Then only you can have a good grip on the subject. And why I want to you that you should do all those things, because if you don't know these intricacies of these ideas, then you will be always followers. Followers means that US or UK or Canada will generate the software and you will follow it. You never can create your simulator yourself. So, my all this discussion is towards this direction. I want that you should able to create your simulator. So, these are the things we have to do, and this is the actually your model. You have to make your model from this data. This is the x values, y values, delta x, delta y, delta z, all these things are given. Here this is the another point I wanted to show. One of the most important tasks of the modeler is to achieve consensus in support of a reservoir representation. This is okay. Consensus means everybody should agree that it is okay. Second, this task is made more complex when available field performance data can be matched by more than one reservoir model. Means your production data can be matched in many ways, that he meant to say. So, how you will know that which parameter is playing major role in recovery? You will never know from modeling, it can be matched in many ways. So, there is a simulator which called WinB4D. This simulator is available with me because I was using it from my time, but at present I think this is they have upgraded, and name also has been changed, you can see, but it is from that book, fancy book. I have shown that book now first. This is taken from this book. So, it was published by US Department of Energy in 1987. It is good starting point to learn reservoir simulation. This is actually what goes on these professional simulators. No, everything is available there. It is a isothermal simulator, Darcy's law in 3D, and we generally learn Darcy's law in 3D, and 3-phase fluid it takes care, and fluid properties depend on pressure. So, these are the things, and this is having two files, WinB4D.exe one file, and I will show you this all to you. This is dat file. This is a dat file where you put all the reservoir data and you run it, only these two files, and you will output file will be time state summary file, run summary file, then OL report and distribution array report. So, these 4 will be output. And can you believe that what can be the roughly average size of this file? This is a simulation. Can you guess? Because you already familiar with existing things. I think you have tried something CMG, Eclipse, all those things. Compared to that, can you guess how much memory or storage is required for this simulator? Very big. And you see some simulator takes how many days?
3, 4, 5.
Yes. So, this big calculation, but you will be surprised to know that this what I should write here. Huh? Hours? No. बोला कितना स्टोरेज लेते हैं. So here what you expect? GB. तुम because I want to emphasize these points. Other things will everything will learn, but this will you never learn. It is KB. That I want to convey. A simulator need not be so large. Why it becomes larger and larger and larger? Because it the precision you give, the calculation will go on increasing, and you will get a very good output. Okay? But what is your input? Your input is not of that precision. No? So, computer can give output very precise values they give, but in this stage, have you seen this in this issue how much data we have? No data almost. With 0 data almost you have to start your simulation. So, how what will sophistication will generate? When input data is not good or not available, not good even it is okay, not good it is okay, but it is not available. So, I am telling this, these two files if you run, then it will generate all this reservoir data whatever you would keep, and I will discuss this after lunch. I will show this how it works, and this simulator having not this simulator, any simulator having two set of data. One set of data is initialization data and second set of data is recurring data. What is the initialization data? Initialization data is that which will not change with time. Reservoir size, some permeability, some parameter, it will not change with time. Those data are called initialization data, and there are many saturation will decrease with pressure, bubble point, not bubble point, compressibility, saturation, all this will go on changing. So, all these data are recurring data. So, any simulator you have to first input, first prepare the initial data and then you populate it with recurring data, and combinedly your simulator will work. And this is one of the files, initialization file. This is primary depletion of an oil reservoir, vertical column model, and grid dimension 1, 1, 4, 3, 3, so many numbers are there and it is very confusing. Then grid length -1, 0, 0, 2000 and like that. So, if you see that it will be very complex. So, what I will do? I will take this simulator, I will show the data and I will run that and I will show you the output. So, means I am telling everything, this simulator takes care of every aspect and still it is so short and fast to work. So, if you learn these things, you will learn about classical reservoir engineering, what classical reservoir simulation works. But my last session will be on simulation in Excel. So, how once you know this, then you can understand what I am trying to do. If I try to do that means directly, you will not understand that what you are missing. So, you should know both, what is the classical thing available and what we can do in a shortcut or in an easy method. I should not say it is shortcut, it can be a very long calculations also, but analytical calculation mostly, and at the same time it will give a confident that this reservoir simulation is very good. Any question in that? I do not know, those are joining online. I think they can have the option of taking their questions in that comment in YouTube, or they can go for Google Classroom. There also they can use their questions, and they can give feedback also, they can give some suggestion also. This is my first effort actually. I should share that I was doing lot of work on petroleum engineering when I was engaged in my oil field development for stopping cross flow. But after getting success of solving cross flow problem, I should say I am not that much interested what I was there earlier, and my focus is not on mathematical learning now. So, in that case, in that time I was not doing anything related to petroleum engineering, but recently I received some request on Mr. Datta. He has called me and he told me to do something on reservoir simulation. At the same time, our one of the petroleum engineering intern Kevin requested, sir, do something about reservoir simulation. So, that ignited my interest on reservoir simulation again, and I am trying to put it. Today I will be showing you all the aspect of reservoir simulation from classical angle and from my calculation angle, but I wish that we will meet again in second time, where I will exclusively work on the simulation model in Excel. Here I am giving a overview of everything and why we require to do a simulation in a Excel model, why it is required, and how it will be done, that will be explained I think when I go for part 2 session of reservoir simulation. So, with that I think we can break for a tea, and after tea, no, now I think we should go for lunch I think. So, we will be breaking for lunch, and then 12:45, 30 minutes, after 30 minutes we will be coming back. Is it okay? Okay, Parth? Yes. Okay. So, thank you. Wishing you to meet at 12:45, 2:45. Good afternoon and welcome back to our third session of reservoir simulation in MS Excel. And now I wish to share one of my screens in my laptop, which depicts the DAS SRL petroleum engineering. This is a material from Google Classroom, and you can see this DAS SRL petroleum engineering, and this class code is NSHDM76. With this class code, if you wish to join, you can join this classroom, and in this classroom there are lot of materials which is I think there are pupils, let me see, there are 49 pupils are there in who have attended this reservoir engineering course earlier, so many of them, and there are class works like that, and feedback, reservoir simulation. Recent posting is yesterday I have posted this reservoir simulation presentation, and you can see this presentation. Whatever I am presenting today, it is available. This is what I should say, a flip book, and this flip book you can just click right arrow, left arrow, and you can see this everything whatever I have taught. So, you can leisurely use it. Those are really serious in learning mathematical modeling, they can use this, and all these ideas and presentation is available, and no cost involved in that, everything is free, and these are the ideas here available, whole presentation is available here. And in future, if I add any presentation, that will also be available here. So, this is Google Classroom. I have sent the code here, and then in addition to that, there are these are the past material. This is IOGC. This paper I presented in China, and this paper is available. This is video of last workshop, and this is also one of the parts, and these are the papers. These three papers I have presented, one in Egypt, one in India, one is China, and all these papers are available here. And this is the very good material. These are 7 videos are there. These videos are I should say it is a very nicely prepared, and you can see who are the budding engineers, petroleum engineers, and particularly those who want to be a good reservoir engineer can see this video. One of the videos I am trying to play, not full, just for sample. I think signal is low, maybe the problem.
Hello and welcome to our first session of Reservoir Engineering courseware brought to you by DAS Scientific Research Labs Private Limited. So our first session will be about properties of reservoir fluids. and we will see the classification of the reservoirs based on the properties of fluid they contain, and also we will look at different methods through which you can determine these fluid properties. For further reference, you can.
So, these videos are available to you for free, and you can view this one, and my request is that this when you go for reservoir simulation, no, you should learn this properties of reservoir fluid first. That is most important thing, and here actually what we have done, we have taken this material from Kraft and Hawkins and explained in reservoir modeling way, and this actually what I want, the geometrical representation of mathematical concept. Here with a geometrical concept, what we are trying to do, we are explaining the phase behavior of reservoir of different type of reservoirs. So, you can see that we have phase diagram, we have created an Excel file, and this is the phase diagram case, and one by one he
Let's look at the fluid which will achieve at the surface.
So, these are the reservoir modeling what we want to do. This is actually geometrical modeling of reservoir fluid. So, anything in mathematics we can explain it in like creating the geometrical model, and my main interest is to teach these techniques, not reservoir engineering techniques. This is used in reservoir engineering, but it can be used in any of your branches of science and mathematics. And he is
Partially liquid and partially gas.
and the presenter is one of my favorite intern actually. For me, he is a great engineer, and most probably scientist also. I have seen his work. He is Anand Shukla. He passed out from Rajiv Gandhi Institute of Petroleum Technology, and after passing he opt for not joining any company. He opt for he came to me and asked me, sir, I want to intern for 1 year with you, and then I want to learn the how we can do research on petroleum fields. So, he was with me for 1 year, and combinedly we have developed lot of things. We have created lot of models, and in that after completing 1 year, he appeared for GATE exam, and he ranked I think 5th, all India rank 5th, and he is now executive engineer in ONGC. So, these are the some of the interns who has contributed a lot in my mathematics project, and I wish that this modeling any reservoir engineer should learn how to model all those things. So, with that I am closing this model. My main intention of showing this video is that how to model even phase diagram we have modeled in Excel. So, and similarly we have explained Darcy's law, then material balance equations, then radial diffusivity equations, and dimensional analysis. These are the topics, very dimensionless variables, dimensional analysis, solution of radial diffusivity equations, and this has a very complex mathematics involved in that, but I think Anand has explained it very nicely in a geometrical way, and it is all having references from where we have taken material to prepare this. So, it is not required that you have to learn from 0. Whenever you face any problem, you can refer to that book. We have written the reference books where these materials are available. So, these are the things, and these are the prerequisite. If you do not know clearly the properties of reservoir fluid, then you can never can understand and learn reservoir simulation. So, this is the prerequisite things, and these doc files also available with that videos, and you can see the doc file, and Excel file also available. So, these calculations how we can do is available for some files, all files are not available. I think it was developed long back. So, this website, and here you can ask any question, and we can assign the assignment here for you, and there is a provision for grading also, but it does not matter whether you grade or not. So, this is for our Google Classroom, and going back to our main discussion, yes, morning we have closed at So, this is the book where from where we will be discussing main points, particularly classical reservoir engineering, what is required, and that book is Applied Reservoir Simulation, and writer is John R. Fancy. This is John R. Fancy's book. So, this is a very good book for primers who start petroleum engineering recently, and they can go through the chapters very crisp and nicely organized book. And first few chapters what he has done, he has explained the principles, and these are the things what is the reservoir management, reservoir engineering primers, volumetrics, what is calculated volumetrics, material balance, decline curve analysis, all these things. Then multi-phase flow. Systematically he has addressed the problem derivation of flow equations, and these are if you learn all those things, then it is good, otherwise also you can manage the simulation. Then Berkeley-Leverett theory, that we have used for, as we have seen that how polymer flood is affecting. We have used this Berkeley-Leverett theory, but not from this book. We have used the LP Deck book. Frontal stability, pattern floods. Pattern floods initially is not required to learn simulation, economics, and these things. And now, this is the overall reservoir engineering in part 1, and part 2 what he has done about reservoir simulation, what is required for reservoir simulation, conceptual reservoir scaling, reservoir structure, then fluid properties, rock and fluid interaction, and you will see that this is required hundreds of data, hundreds of different parameters, and in addition that reservoir parameters, you require to add hundreds of additional parameters which control the behavior of the reservoir data, reservoir parameter. So, in that sense you can say that reservoir simulation file, the input data file is a very large data file. So, lot of things are there, but it is so if you learn this taken and reservoir structure history, model as initialization, what is called model initialization. I told you initially this is the data which will not change over time. So, model initialization, then history matching, prediction. And lastly, in chapter part 4, he has introduced one simulation model. This is actually we will work on this, and you will see that this simulation model win B for D dot exe. This is a simple file, and when we run, I think it is written in Fortran, and when we run this program, it will take data from this data file WTEMP data file, and in the data file these are the data: grid dimensions, seismic velocity parameter, porosity permeability parameters, then rock, PBT, relative permeability, so many things are there. But here you see it is 10 parameters you can think, but each parameters having again hundreds of other parameters. So, to control this parameters. So, next recurring data well information, time step means when you put output at what frequency you want the data, the number of frequency you increase the file size, you will go on increasing. So, like that program output evaluation, how you can evaluate. And lastly, this 4 is the about technical supplementary theories behind this simulation, and all these details about how to enter data. So, with that I am these are the basic things, and with that what I will be doing, I am directly going to the Win B for D simulation package. I liked this flow and creeps. It is not very highly elaboration long text. It is not like that. At the same time, all the important things are given, and every chapter he has given 1 2 example, and these examples are related to that simulation model. So, you practice this exercise, you will learn how to handle those simple simulation. I will go there, I will explain how to do that. Sorry, I can go directly to that. This is the file where for simulation model data. In this file you have to enter all the data, but when I explain this file you will feel that it is very complex and difficult thing to do. I am slowly going one by one. Here first we are doing grid dimension and geometry. It is starts with this, and you can understand that it is why it is required. It is actually we are creating a reservoir model, and this model first thing come II, JJ, KK, IO, ROK, IO, PVT. These are the some codes, and it will be very confusing what is that. But it is actually when you learn these things. So, it is very easy thing. This is telling first you have to write what is the number of grid blocks in x direction, number of grid blocks in y direction, number of grid blocks in z direction, IORK, IOPVT, and these things. So, first you have to write these values 1, 2, 3, 4, 5, 6, 7, 8. I will explain one and then I will tell the pattern in that. So, when we go for a reservoir simulation, no, what happens actually you have to make a model. So, model will look like that, front view. So, it is a reservoir model, and it is telling that this is first cell, second cell, third cell, fourth cell, seventh cell. So, in that way if you think that it is first cell, this is second cell, this is third cell, this is fourth cell, this is fifth, and this sixth. And here if you go up, this is second, third, fourth, fifth. So, horizontally or x direction it is having 6 cell, and vertically it is having 5 cell. Okay. So, first II is that how many numbers of grid blocks in x direction. So, here we have to write 6. So, this looks about jumble, but it is having a pattern. So, you are describing this. Then you are JJ, this number of grid blocks in y direction. So, this is actually y direction 5. So, next data will be 5 in this case. So, this is actually what I have taken x and y, but in normal case what happen, x and y is in horizontal plane, and vertically it is we are standing here like that. So, in actual cell this is the thing, and vertically so this is the third one KK. KK is means I am taking 4 layers are there. So, combinedly how this thing will come? When this 2 is 2D, no? So, 2D combined it will be something like that. So, vertically 1 layer, 2 layer, 3 layer, 4 layer, same thing will be there. 1, 2, 3, 4. now in x direction is this. So, here 1 2 3 4 5 6. So, 1 2 3 4 5 6. Similarly, if you calculate y direction, it will be like that, and you have a mechanism to do that, and it is very easy to do that with Excel. And today I will not teach you how to do that, but I will give a idea of how we do this. So, like that every parameter having a code, and you have to put that code and you have to learn, and first time you will feel that there are lot of codes and you may not able to remember all those code. It is not my cup of tea, you will feel like that, but it is not like that. It is all having a pattern. This codes having either a number or a particular pattern, either it is -1, 0, 1 or 1, 2, 3, 4, and if it is 1 then there is a value, if it is 2 then there is a value 3, like that. So, everything having a pattern. So, majority of data set of this will be having which is not related, and these are not related any reservoir properties. This is we are creating the property, is it not it. So, in addition to reservoir parameters, you have hundreds of other parameters related to simulation, and that is why simulation becomes so complex. It appears to be complex, but you slowly step by step go, then it is required. You have to have a model like that, and the data is required for creating that model. So, everything related, it goes like that. So, I am going ahead with that. Here again here data also grouped in some major headings. So, first heading is that if you remember, I will go back again. There are 10 15 major data which have some sub data. So, first data is 24.1, you can see here 24.1, this is grid dimensional geometry, this deals with that. So, the entire section whatever is discussed is grid section. Then 24.2 if you go, in future when you refer back to this book, no, it will be easier for you, you need not scan from 0 to 100 again. I am giving you ready made, and here you will not learn unless you practice it, until you try it. So, again 24.1 is going on. This 24.2 seismic velocity parameters, this is some parameters which is seismic data you have to put here for 24.2. So, major groups I am just highlighting. It will go, it will having many sub datas. Then porosity, permeability, your model is ready, that seismic data is ready. Now, you populate it, it is called population. Now, your grid is to be populated with porosity, every grid having what is the porosity, permeability, transmissibility, all these things. Then it will come section 4. So, 24.4, you can go to 24.4, and this I1 J1 is the means first cell number, last cell number. J1 direction means y direction first cell, J2 is y direction final last cell, K1 is the vertically first cell, and K2 is the vertically last cell. So, these are the appearing that very complex data, and I will show a data file also, that you will understand what is how simple it can be. So, 24.4. So, here rock and pavity region. So, here we will be this model, but this model may not be uniform. Here there will be a region where property is different than this region, or this property can be different from this region. So, you have different option to define particular region. You can populate it, you can have different PVT data, rock data on this. It is not that all should be same. So, PVT rock and region, and then 24.5. This is relative permeability. Again, that relative permeability I have shown earlier, that plays here, and that is to be defined, and data is same whether in Excel I have given or it is there, and you can see this is written saturation KROW, KRW, then KRG, KROG, KPCOW, the capillary pressure, oil water, capillary pressure, gas oil, relative pressure of oil, like relative permeability of oil, like that. So, it will go like that. Then fluid PVT tables. So, this fluid PVT tables, again what we will do, how it changes with pressure. You can give them slope and ask them to calculate, or you can give the data directly. This is the P1 is pressure, mu means viscosity, Bw, Rsw, this having formation volume factor of water, viscosity of water, residual gas saturation, no, not residual, this is such gas saturation, like that, water solution gas oil water saturation, sorry. So, like that it will go like this for oil water gas, all these three. Learning this way, all the commercial simulator also follow same, their name may be different, but data will be same. So, pressure and saturation initialization, in that case you will be giving all this, and run control, this how you want your output should be. Then if there is aquifer or not, you see this aquifer or not, your number is IAQOPT. So, if IAQOPT is 1, no aquifer, 1 pot aquifer, 2 steady aquifer. So, here this code is to be replaced by 0, 1, 2, 3, 4. So many you can see that Carter-Tracy aquifer model RE by RW is 0 to infinity, like that it will go like that, and then this is the second part of this data, this is recurring data. Here time step and output control. This information is means data is to be same, but the nomenclature will be different for IMAX or STAR or CMG or Eclipse anywhere. So, these are the things, and program output how it will be. You can get this data as output and these files as output. These are the temp TSS time step summary file, then plot file, then ROF file, that pressure saturation, all these things will come here, and oil file. So, this will be 4 files, output files. This is the nutshell of what goes on reservoir simulation. Apparently, it is a huge data and huge subject, but if you group it, it is like that 10, 15 parameters or groups in initialization phase, 3 groups or 4 groups in recurring data phase, and that is all. And now I will be showing you a data file, and then I will run the simulation model also. So, this is the Win B for D simulation package. Now, it is not available, what I feel. They have improved it, and name might have changed, but the ideas of this is almost same. So, what I will do, for an practice I will create a new file, new folder. So, here it is an empty folder, you can see again reservoir simulation, empty folder, no folder is there. I am trying to show you how simple these activities can be, but if you try to learn in classical way, then it is very complex and difficult, and it is very difficult to learn everything in classical. Once you know these things, then you can go there and you can learn that classical way. So, I am telling learning purpose, it is best. Now, you can see this, can you see this? So, anyhow, so this is the 957 KB file, only 957 KB. So, when we run it requires a data file, from where it will take the data. So, how they do it? It has a special option of naming. That naming is this. No, any file is named with this, it can take. This is the paper of this Havlena Ode for calculating the water encroachment. So, this was single file, now I am taking the dat file. So, this dat you can open it any file, no, with sorry. Now, if you see this dat file, this is the data file. Okay. So, all these parameters I was explaining there, it is corresponding to that numbers. So, if you are willing to work on this, you can see this number from the relevant files. So, first was do you remember what was there I, J, J, K, K in that. So, here it is written not I, here it is written 1 1 1 3 3 30 10 30. So, here 1 1 1 is means here telling one cell in x direction, one cell in y direction and one cell in z direction. So, their simulation model is like that. This is a tank model, this is called tank model. This is a tank model, one cell here, one cell y, one cell z, that is all. And then other values are depending on that, and this is actually from this, as I know what actually it is telling that in one direction 2639.7, it is telling this x direction 2639, 2639 and something like that. So, 160 160, we have to see that what is meant there, I do not remember actually. And third, depth of top of upper sand zone is 7315. So, at from surface if we take, this is 7315 feet, like that. So, this is the data file, and here you see this saturation, KRO, KRW, KRG, all this data are there, PBT, rock PBT, and you can put all three region and bubble point pressure here, bubble point datum at which depth, then V slope and this P mu g pressure with viscosity, formation gas volume factor, then compressibility, PSI is 0. Recurring data 1, these are the recurring data is related to well data, and it is having different meaning, and it is showing there is one well and new well and under production. So, these are the data file, and then if I run this win B for D, let us run it, okay. Double click, it will run. So, when you double click, it says that this software is licensed for the exclusive use of the original purchaser on one computer only. So, it was available with book. If you do not have that book, you will not get that CD. I think you can check with your library, you can get it. And send output to files, here you can tell N or Y. Y means yes, you create a file, and that file will be a text file, and N is there, it will not create any text file, but data will be created. Here I want to see that data which is created, that is why I have I am writing Y, enter. So, this is the output file. So, how much time it took? Microsecond. So, this actually goes on in reservoir simulation, and you can see that in days it has calculated serial time step day and days 6 day, 12 days, 30 days and like that, and up to 360 days in for 1 year it has printed. You can increase that parameters, you can change. So, what was the oil 600 barrel per day, and GOR is this, water oil 0, gas 0, water 0, and PV pore volume average reservoir pressure is this, and it goes on. So, it goes on production like that. So, is there decreasing, slight decrease in production. So, this data you can take in any Excel file and you can plot this. Now, you see we have two files WTM dat and WinB4D exe. Now, it has created, you see, WTM ARR file, array file, then PLT file, then ROF file, TSS file and OL file. These are the OL file. What they have done, whatever you got in text file, all these are segregated for its relevance one. So, where you want you can see that. Now, there is a provision for seeing this model also. So, how you can do that? There is a file called 3D view. 3D view I was not taken there. So, I am now copying it and putting it here, paste. So, now it has a 3D view file is there, but now if you click 3D view, nothing will happen, this execution error will come. So, why it will come execution error? It is also required, now you require to some extent coding knowledge. So, actually any exe file is to run, it requires some DLL file, dynamic link files. So, DLL files if you copy, then it will run. So, here is the DLL file, you can see that our main program, and these are the DLL files. So, copy and paste. So, now DLL file is this in this folder, and now click in. So, this is a command from file, and now you click on file, array file, and then array file it has taken. I think let us see, okay, nothing is visible here, but actually something happened, but I do not know. This file actually it is there, display pan. So, this is, you can see this is your one by 1 by 1 and 3960. I think this has taken 3960 and some data are there, and there are lot of thing is there, spotlight, rotate spot, and then model, active oil model, adjust light model. You can slice it if it is 2-3 grid model, then you can slice it and see that many options are there. It appears that it is a very simple model, but I don't know how to use this, so it got stuck. Project change Z aspect is that if your file is height is very good, very long, then it is become problem to display. So, you can change the Z aspect to see smooth. So, what I mean to say, there are lot of options available to visualize. So, this is an file size. You can see that file size 521 is the view folder file, and DLL file 1 KB, all KB, and now we still use 1 TB file laptop, and still we face problem. So, what I should say, we are improving technology and making our life more complex in the search of perfection. What perfection I want? Actually, how much perfection? I had lot of problem yesterday. You don't know. I was about to cry when I in midpoint of my presentation, that main file where I was working, that this is my second case. One case happened when I was finalizing my one book, final book. So, in later phase I was facing lot of problem when I am taking this file in email, taking back and keeping track of which one is the latest file. So, in last phase what I have done, I was not taking it any copy, I was keeping one copy and working on that, and I completed whole correction, and it was about to go to print, and I connected it to my printer, and what happened suddenly I do not know, that laptop hard disk is blanked, and I could not recover even that hard disk, and every effort again I had to do all those work from scratch. Yesterday also I have, that is new HP laptop, and I recently changed to SSD hard disk. So, old 1 TB hard disk is there, and I have additional 500 GB HDD in that. So, that was working very nicely, and I was presenting all my papers in that, because they are having this is to some extent old, 2 years old. So, lot of data is there, whatever work I do, so all files are very heavy files, 30 GB, 40 GB installation files itself. So, that file I was working, there was lot of space, and at the midpoint when I was almost progressed a little bit, and suddenly that hard disk also corrupted, and I could not recover. Again I have to do all these things whatever you are seeing now from zero. So, yesterday I had a lot of problem, and that too again that IPL final. I was not interested in that IPL final, but others are interested, no? So, it disturbs, and last page they took it up to, have you seen this yesterday? No, not night. You have seen how long they pulled it, that prize distribution ceremony. Up 12:39 1. So, I was there up to, because last page what happened, let us see what happened, let us see, like that it was 1, and my this presentation was also not that much complete. I was to some extent nervous, because I have to tell it goes directly to the TV, no. So, I should not come unprepared. So, anyhow this is okay. I am happy that what I wanted to convey I could convey properly, and God sake that yesterday night, late night I went to bed, still I can feeling comfortable. Yesterday I was feeling that if I feel tired or not. So, about the surface, one thing I wanted to show, these are the prepared in what I should say 3D printers, yes. And 3D printers, what is that? It is the function of two variables. So, input was that function of two variables and output is this surface. So, that mathematics of this is required for modeling. So, contour map, when we talk about contour map, if you do not know that how these contours are created properly, then how it is populated, and then how this thickness grading is done, and why to grid coarse grid, when to do fine grid, and at the same time all the function of two variables need not require to create such a nice surface. Some surfaces can be like that, and in that case it can never be a reservoir, is not it. So, if you depend solely on computer without knowing that how these surfaces are being created, what was the requirement for a contour map, means contour map means it is 2D map. So, how it converts to 3D, all those things is required. So, it will be just mechanically you will be doing reservoir engineering, but you will not have any confidence on what you have done. So, if you require to be a good reservoir engineer, you should have clarity on all those things also. And when you go for mathematical modeling, you have to do it and then you will learn all those things. Initially it may take a little bit more time than learning normal situation, but this when you learn these things, it will be your lifelong asset. Your confidence level will go up. You can face anyone. And this is my say about this. And now I will be breaking, and I will be come back even after 10 minutes tea break. Okay. So, stay with us, and we will not take much time, 10 minutes we will come back. welcome back to our final session and fourth session of reservoir simulation in Excel. And almost you can say to up to this whatever I have discussed about reservoir simulation is the basics of the requirement for a reservoir engineer, what is required to be done and how reservoir simulation is to run. In that process I have shown that win B for D that was developed by John R. Fancy and he had developed it for US Department of Energy. So, and US Department of Energy is used that simulator and distribute it freely, and this was the case. And we have seen that how this classical reservoir simulation starts and what are the data required to input for that classical reservoir simulation models, and seen that it requires many data to complete a reservoir simulation model, and this data almost in the initial phase of that oil field is mostly unavailable. So, what to do? So, this is the thing. My perspective is this from that angle that I do not have much data, and I cannot say that I cannot do my job as a reservoir engineer. I will wait for 10 years to generate a lot of data, and then I will give the production field development plan, but it is not a good way. So, I have to do it, and how we can do it that I will be discussing now, and that is the reservoir simulation in MS Excel. And this file I will share with you through Google Classroom. You can this is an Excel file and you can download it and you can try it, and I have given that maximum information on that as far as possible, but still if you require something you can again contact me through our WhatsApp group, reservoir simulation group, and there are Google Classroom, and at the same time you have this all event registration link. They are also having provision for inbox, and there you can write anything also, and everything I can get a notification for that and I can act accordingly. So, whoever is available here and who could not find full time to see this, they can see the video, they can be interact with other at post workshop also. It is very welcome to all, and not any fees required. This is my voluntary service to the society. So, when I start this Excel simulation, again the same question I ask, where to start and why. So, where to start and why, this is the thing what I should explain. Suppose I have discovered a field and it has n quantity of oil. So, I do not bother about n quantity, I take it 100% oil. So, left hand side is the our reservoir, and right hand side it is having a tricky figure. Some part is yellow and some part is at brown color sort of thing, and bottom it is written mobile, and right top it is written immobile. Can Ishan tell me what does this mean? You can take mic. This is the starting point of reservoir engineering.
Out of the 100% of the discovered oil, 70% is moving. I mean, the viscosity is enough that we can bring it to the surface. 30% is so viscous that it is not moving.
Very good. One answer we got, viscosity. Now Parth.
Sir, again the reason is the viscosity, but there might be a chance that the oil will be the zone where we can't get to, means the permeable zone, impermeable zone.
Is it like that? Okay. So, this is a starting point, and when you go for classical reservoir engineering, no, it will not teach you what the implication of this. So, actual what happens when we discovered any field, on an average 20 to 30% oil is immobile. Immobile means it will not move, whatever you do it will not move, and rest 70% approximately is mobile. So, what does it mean? It means that yesterday some cabin or someone was talking about this one factor that is responsible for this, but it is not like that. It is a portion of the oil. Suppose initially, as I told, that when oil is migrated to a pore, that pore was not empty, that pore was filled with saline water or sea water. So, water was there already, and that oil when migrated, it entered into that pore and replaced that water. So, now grain is there, all grains, and in grains there are pores, and in that pores there is water, and in between that water oil made its path, or you can say residence. It resides there, no. So, very bad oil. So, now we had in reservoir rock, water and oil. This is the normal for almost all water weight reservoir is like that. Forget about, we are not talking about oil weight reservoir, that is another chapter. So, all water. Now, what happens actually? Why I say 30% immobile? It means that when we suppose now oil water was there, now oil has entered. Now, suppose again I push water outside, from outside I push water. So, what will happen? That water now push the oil, and water whatever may be, it will, I am when injecting water, it will try to push out whatever there in the port, but in that port what was there? Water and oil. So, it will try to push every both. So, in that process what will happen, that water and water, they are same phase, no, same thing. So, they imbibe each other, they attract each other. So, that oil water will tell this water come, because he wants to increase his quantity. So, and oil what will do? It has to move out. So, oil will move out and this new water will enter, and in that process if I see this is a, suppose a circular pore I should say. So, circular pore, this was full of water initially, water. Now, what happened? Water is there, but some oil has entered. Okay. Now, what I am doing? I am pushing this with water. So, water is coming. So, here what will happen, water quantity will go on increasing, this water will go on increasing and oil will come out here. Okay. So, when oil water come out here, say in center part oil was there, that oil quantity in the center will go on decreasing. But what will happen, it cannot push all the oil. Whatever pressure and whatever quantity of fluid or inject or water I inject, I cannot push every oil out. Oil will come out, it will continue coming out, and in that process the water saturation will go up. What we tell about water saturation. But if we forget about what layman term, water quantity will increase here and oil will come out. But in this process it appears that every oil will come out, but in reality it never happens. In reality what happens, this oil, some oils will be trapped here, and what is the trapping force? Neither permeability, neither viscosity. What else can be? Can just from general knowledge of thing, can you tell something? Why it, that center portion, the droplet of oil will remain there? Why it will remain there? I am pushing suppose 5000 psi, 10,000 psi, still it will not come. Okay, I can explain that. This is due to
Something related to solubility. Like
solubility means this is okay. Okay, carry on.
Like if we have salt solution and we keep on adding water, the concentration
same water. I am produce water. I am injecting.
No. If the concentration is continuously decreasing, but
what concentration?
Like if we have a cup of salt solution and we constantly add salt to it.
I am putting same solution, same salt solution.
Same salt solution?
Means whatever they are.
No. Now, if the salt solution is there and we are constantly adding fresh water to it.
I am not telling I am
injecting this is
fresh
different
water. I am injecting salt water.
I am using it for a different metaphor. If we are constantly adding fresh water and we are not removing the salt content, actually maybe the concentration is increasing, is constantly decreasing, but because the salt is not removed, the concentration will never become that of a fresh water. Similarly, we are constantly.
You are just assuming I am injecting fresh water. I am telling I am not injecting fresh water.
No, but like in this case, we are constantly adding water.
Salt water.
Salt water in that oil.
Reservoir water I have produced from other oil, and that water I am injecting here. So same water I am injecting. Then.
But because all the oil is not. No, that doesn't fit in. Sorry, sir.
Okay, no issue. So these are the things. This is a small things, but this knowledge is very important to understand what happens. Actually happens a surface tension of water and oil. So they surface tension try to hold each other. So at certain saturation, the oil will go out, and then certain condition will come when the interfacial tension means oil and water, this interface, that tension is so high, it never come out, and whatever you inject water at what pressure itself, it will flow like that. you are continuing the flow. Flow is not holding. So, now water will not enter into the port, it will bypass like that. So, it will not push that oil droplet here. Got my point? So, no. Okay, I will try to make it. Many other things you will get in book, but all this explanation it is there in book, but you will never realize until unless somebody explain it what it means. Suppose you have this and this is your oil portion, because this oil has entered. Oil I will you can see it is rock. And what is this portion? No, rock it water, yes. So, you can say this is a bottle. Bottle was full of water. Now, I have put some oil in that and oil has entered inside, but all the water will not come out. Some water which was stick to the rock, that will remain and rest of the water will go out. So, now it is like that a situation. Now, you are started injecting water. So, what will happen? This water go on increasing here. When water will go on increasing here, so it will push this oil, no, this oil will push and this oil will come out. So, certain percentage of this oil will come out. When oil will come out, that situation will be like that, your pore is still there and your oil rest, what has happened? Some oil has come out and some oil remain here and rest is water. Okay. Now, this is the condition where if you further inject, then this water will come like that. It will not push this oil portion. You got it? And this is not mobile. This is called immobile oil reservoir. And you normal course. So, whatever oil was there, what was the mobile, it will come out, and what is not mobile, it will remain there. So, whenever we put some reservoir, discovered some reservoir, this is the normal situation, and then we try to produce this 75%. We do many things. We try to produce it in depletion mode. We told it will be 14% something. We try to inject, but even we cannot produce with 70% from that. So, this is the problem, and this already I discussed. So, in reservoir in oil field, Shannon field, what happened? Though this was at the top of the reservoir, but it was producing water. So, these are the calculation we have done, I have shown, and these are the few data we have. You can see now, these are the few data we have, and from that I have to predict how this reservoir will behave. You can see this is the only data. Reservoir pressure we know, gas gravity we know, oil API means oil gravity we know, reservoir temperature we know, and bubble point pressure we know. We do not know anything else. We do not know the extent of reservoir also, forget about model. So, how we can simulate this reservoir? So, one thing we know that this reservoir bubble point is 100 kg and reservoir pressure is 142 kg, and we can calculate this RS CO. RS means solution gas factor, then compressibility, then formation volume factor. What is the formation volume factor? Any idea? Mike?
Volume on the surface divided by volume in the reservoir.
Now, what is that? How much? What is the value for that?
Value for that meaning?
BO.
Hmm?
Reservoir volume by this volume, the average value what we can get for BO.
Greater than 1. Greater than or equal to 1.
What is the significance for that? Greater than 1, what is the significance of that?
When any pressure at the surface will definitely be less than the pressure at the reservoir.
Yes.
So the fluid is definitely going to expand. The extent of expansion is given by BO.
So, what you mean that suppose 1 ton oil is there, so it will become 1.1 ton at surface?
No, the volume will increase, not the mass.
I am talking about volume. So, 100 cc oil was there in reservoir, so it will become 1100 cc. Pakka?
So water production
Don't mix anything. When you talk about any parameter, don't think about other effects. So, in life also concentrate on one thing, and everything is integrated, but that effect we will discuss later. What happens to the oil?
gas will liberate due to pressure reduction.
Okay, it is known. So, I am talking about oil volume will increase, decrease or remain same. 1000 suppose 100 cc was there at reservoir, it will become 95 cc or it will become 110 cc at surface.
Oil volume will remain same. But
At when surface, when it come to surface, then why we use BO?
sir, because gas will liberate, so volume will increase at surface condition.
So, surface it is increase.
Yes.
We get more oil than reservoir in volume.
Yes.
Agree? Actually, it happens opposite. When we bring that reservoir to the surface, then what oil volume decrease. If it is having 100 cc, it will be 95 cc, 98 cc, depending on BT, BO and BT. So, this is the thing, and the recovery factor also depend on that BT and BO. Initial formation volume factor, final formation volume factor divided by initial volume factor, that gives the recovery factor. All this has been calculated here, and you see we have water saturation 60% in this reservoir, third column you can say, and then correspondingly oil saturation is 0.45 means 40%. Gas was not there because it is a undersaturated reservoir, and then this is gravity in psi per feet, mud weight equivalent is almost hydrostatic, and this is the recovery factor with when water and rock compressibility is taken care. So, in normal case RF factor is this 0.001 and percentage wise means 0.1%, 0.2%, 0.3% like that. So, these are the thing, and which is related thing. This is related initially, you see, I told this is the initial reservoir pressure 1991, and this reservoir pressure is decreasing. When I produce, then pressure decreases. When that pressure decreases, then pressure decrease, I have taken some use some formula to uniformly reduce the pressure, and correspondingly R A. So, was 142 and now it is 100. So, 42 kg per centimeter square decrease, and we should recover 2% of initial oil, 2% only. So, that was there, and when you see this then brown one, it shows when we take into account compressibility and rock of compressibility of water, it will be little more. But in actual case, this pink color, this was our pressure and production behavior. It was not dropping, pressure was not dropping in spite of we are producing more. So, that is the indication that something is, when we are producing, we are not injecting anything, no. So, pressure should drop, but it is not dropping, that means it is some aquifer is pushing it. When the oil is producing, the aquifer is expanding, and that aquifer strength here also we can calculate that strength is very high, in the sense the aquifer is very high, otherwise it cannot maintain that pressure. Okay. So, this is the thing, and then after that what happened, it is cutting water. This is the second problem. So, what was the cutting problem? We have calculated this, it is from aquifer, and then this aquifer calculation, all this available in this model, if you also calculate, and there are formulas I have given. And here the problem is viscosity of this oil, it is 20, and when water viscosity is 0.38, that is why it was cutting, started cutting water. So, here we, if we use that water viscosity, if we increase the water viscosity, then we can improve the mobility ratio, and then we can get more oil. So, this calculation I have taken this LPDEC book, and mu O I have taken third row, you can see 0.05, 2 and 8. This is the oil viscosity. So, in general oil viscosity is 0.38, yes 0.38. So, if I increase it by 2, then we get some mobility, and you can say that when water viscosity is very less, mobility ratio is 9.8. When the water viscosity increases, mobility decreases, and this when mobility ratio viscosity is 8, then mobility ratio is 0.44. So, what is the effect of all these things? This is effect, this can be calculated from this KRW and KRO curves, and these are the fractional flow. These formulas are also there in Excel file, and I will share this file. You can see this calculation, and at the same time you can check it with this LPDEC book also, how it is calculated. If some mistake is there, you can correct there, and this takes care, and this is the water saturation SW. So, SW goes on increasing, then you see this curve means it is immediately not water flow is increasing, though saturation increasing. So, that is desirable, because more water is entering here and water production is not there. So, water production is not there, so something is producing, so oil is producing. So, we are producing more oil with less water. So, this curve is desirable, but when we started our Sanan field, it was following this path, and this path it is will be 100%. So, this much water saturation, it will become 100% water cut. So, immediately So, all the water oil will remain and it will go on producing water. So, that what we have done, we have started injecting polymer here. So, when we polymer here, so it curved came like that. So, whatever now it was increasing water flow, fractional flow of water, water was producing more. Then after this viscosity increase of water, water production came down and then started following this curve. So, that was the advantage of thing, and this all calculation has been made. This is the effect of this how oil gain is there, and all this means water compressibility and rock compressibility when taken care, it will be formula is there, and all this formula what I have used, I have written here RS equation 126 page 33 of Kraft and Hawkins second edition. So, this book and this is the formula that we have used for RS calculation. Actually, in book all these calculations are given, so so many factors are there, no? Everything they have to give, and it is very difficult for a learner to identify isolate. As you are telling that when water saturation case, then you are thinking some other parameters. So, they have to think, but individually how it will work, that is given. So, this is compressibility, how we have calculated. This is in 1.33 page 39, then bubble point at bubble point pressure, BO at bubble point pressure 129 equation. Then when BO above bubble point, then it is equation 130. So, all this equation is there, and when we pressure drops, then what happens, this jet factor, initially there will be no gas liberation, but below reservoir temperature bubble point pressure, this gas compressibility factor, gas will evolve, and we should take care of this gas compressibility factor also. So, jet calculation is also important. So, jet calculation we do here, and here we jet factor calculation we use this Dranchuk and Abu Qasim correlation, Kraft and Hawkins, page 17 to 26, second edition book. So, how it works, you can see these formulas, and you can understand that how it has been taken here. We take a one initial thing, then we calculate some parameters, and then this another formula we use, and this formula we take here, and it goes on like that, and it is a iterative method of calculating Z, and this is a correlation. Otherwise, we have this chart in oil field, there is monogram and monogram chart, you can find the jet factors, but in chart we when we go for simulation, we require different values of Z for different pressure. So, that you require some formula. So, this is an empirical formula, this is not exactly in the a formula derived like PBT formulas, but it is good, it is almost 0.5% accuracy you get the jet factors. So, jet factor here we calculate separately, that jet factor we use in calculation or simulation of this, and all the other factors are calculated here, and this is pressure related. So, there are another file which is we are required to use is I am happy that I could explain whatever I wanted to explain without pressure. There is no time pressure. So, this is the oil's displacement efficiency. So, that calculations that what happens is mobility when is not conducive, when this adverse mobility is there, then what is to be done. These calculations also done very nicely, and we followed this calculation with LP deck book page 350. Here if you see this formulas, and if you are good in Excel, then you can see these formulas, see, trace this, define. Here up to here, or you can see here, and you can see formulas, trace formulas, show formulas. There are anyhow, this is not appearing, but it is there, show formulas. So, you can see the formulas there. I think I have expanded that, so it is not coming, or don't know what is the reason. It should come somewhere, show formulas. Okay. Otherwise, you can click it and you can know, see this formula. So, these files I will be sharing with you, because this is my own created file. So, no copyright, nothing is there. So, you can freely use it, and once you learn these things and refer this Kraft and Hawkins book interchangeably with this, then I think you have to spend time for that, but I feel that you will reach there in a shortest possible time. Without this guidance, I think it will take long time. Even I think it is very difficult for someone to do all these things what I have done, because I was doing these things, the time I spent, it is not simply possible to a normal people, because they have to be eccentric. Then I used to go IRS in the morning 5 o'clock, coming back at 11 o'clock night, because of this license. License was very crisis. There was 1-2 license in simulation, and the people assigned for their project, they can only use those licenses. So, I used to go early morning, so that before they come, so that I can use it, learn it. Again late night when they are not using, I had to go there and learn. So, it is simply impossible for a person those are in normal balanced life. So, I made that thing so concise that you can directly use A to Z without spending much time. So, that is my objective of this workshop, I think. And next time when I will come, if you help me, I will convert all this mathematical modeling with geometrical modeling. So, if you are willing to take this challenge, then I can. Here still we are depending on these curves, is not it, different curves, and we have to infer that it will work on that curve. But what is the geometrical modeling? We create such models, and we will effectively show that why this residual oil saturation, or that bubble, why it is interfacial tension, how it is pulling back this oil percentage, that immobile oil percentage. So, you can see geometrically how it is working. So, with this I close my presentation here, and those are joining from online, They can send their queries, anything, comments and feedbacks with Google Classroom, and you can also provide feedback how you liked it, and any question you have you can ask me now. This model is a flip book and very nice. You can use this presentation, whole presentation I have made it a flip book on that. So, this is also you can enjoy while you read all these things. You can send me some suggestion also if there is any scope for improvement or to add something, that is also acceptable. With this, I will be, if there is no question, I will be closing this session for today, and I have another workshop on complex analysis. Complex analysis on 3rd June 2022, and this will be much more interesting, and this is required for all the practicing engineers, students and faculty members, that why we require complex number at all, where would we use it, all these things will be discussed, and A to Z means whatever is related required to be learned for a higher studies, everything will be discussed in that workshop, and it is for school students. Those are from 8 to 12, anyone can join, 8 to 12 anyone can join. It is not that class 8 student cannot learn complex numbers, they can also learn, and I wish that school student join this workshop. With this, I will be closing my workshop here, and see you on 3rd in complex analysis session. Thank you.